Hello and welcome to the October edition of the Altair HyperWorks Insider Tips and Tricks video series. So this month we're going to talk about a new mode of hypermesh, I guess is the best way to refer to it as, and it's the basic FEA user profile. Now the basic FEA user profile is really designed for the novice FEA user, somebody who doesn't necessarily know the ins and outs of running an FEA, or it could be used by an expert FEA user who just wants to quickly run an analysis. So this can be accessed a couple of ways. First of all, we can just straight run HyperMesh, and when the user profile selection window comes up shortly here, we can then select from the list the basic FEA user profile, and it puts us in there. The other option is when you go to your All Programs menu here, HyperWorks, we do have a direct link to the basic FEA user profile, and it will take you directly to that interface. So the interface is a very streamlined look and feel to HyperMesh here. We've completely removed the panel area, opened up this the graphics window. Got a whole new set, or a bunch of new icons along the side here that we'll talk about them. But as you can see, it's a very minimalistic view, and the idea behind that is we really want to make this as easy, streamlined, and straightforward as possible. So everything's going to be driven out of the browser area here, which is a new in this basic FEA. Tab is a new tab there. So let me open up a model. Now I'm just going to come here and I'm going to open up a HyperMesh model, but I could have very easily just gone ahead and opened up or imported a CAD file, because all that this file is some geometry anyway. So the usability is the same as with HyperMesh. To rotate, to pan, to zoom. We have our wireframe and shaded geometry modes here, just like in HyperMesh. But what we're going to do is we're going to work entirely in kind of a geometry mode. The meshing is really going to be pushed to the background. Again, this is really originally designed for the engineer or the designer who isn't necessarily familiar with finite element analysis. So we're going to put that mesh kind of in the background and leave it in behind. If I want to see the mesh, of course, I can just come up here to mode, change to the mesh mode, and it'll quickly mesh it. Now, the one thing that you need to know about the basic FEA user profile is this is a solid only type situation. So it needs to be a solid part, and it's going to go ahead and put a tetrahedral mesh in there. But as I said, we really just deal with the geometry. So we're just going to leave the mesh entirely in the background. Now, this is definitely something new to you HyperMesh users out there. There are units in this. I know that HyperMesh is unitless, and we've taught that for many years. But as we're really trying to make this an easy approach here and leave the details of analysis in the background, we're going to make this easy, and we're going to put units right in there. So I'll just leave it in these inch, pound, second unit scheme. So you see it's brought in all of these parts here. It's created different parts. Of course, the HyperMesh user is going to know these as components, but we're going to call them parts, because really that's what we're dealing with here are individual parts. And for each one of these parts, what I can do is I can just right-click on it. It's going to highlight the part there, and I can select a material directly from here. So we have a standard material database, some commonly defined materials. I can also come to the database here, and I can come to this My Materials tab, and I can add a material. So I just come in here, I can put in the values, I can rename it, we'll call it Eric's material, and I can put in the values here. And when I come back to the library and close that, and I right click here, I can see I've got Eric's material, and I can assign that. So I can go through each one of these different different parts here, and I can assign a different type of material, one out of the database, or create my own. And then I just continue moving down the list here. So the next thing that we need to address are contacts. So this is a number of individual parts. They are not connected together, but in this case we want them to be connected together, and we have this option here of right-clicking on the contacts, and I can come to Auto Contact and select Create. And what it's going to do is it's going to quickly in the background mesh this, and then it's going to look for components or parts in this case that are touching each other or next to each other, and it's going to automatically generate a tied contact between them. So now everything becomes locked together. I don't have to worry about nodal connectivity. I don't have to worry about connecting things together. I just straight create a contact here. And it will show me all of the different tied contacts. And if I click on it, I can see the two components that are tied together. I can change it to a sliding contact. That's a little bit more advanced, so we're just going to stick right now in this demonstration to the tied contact. And each one of these, I can then see the two components or the two parts that it has tied together. Then I continue moving down the list. I come down here to the analysis section. Let me just minimize that so I don't have this long list here. And I come to analysis, and I right-click, and the key to this is just to right-click on a section. It'll give you the different options, and what I can do is create a load step. So now it's going to ask me what type of analysis I want to run. I can do linear static, normal modes, buckling, sliding contact, or a fatigue load step. So I'll just select the linear static load step here. It creates my linear static. I can, again, right-click on this, and now I have the option to create the different things I need for this load step. So I need to create a constraint, and I can create a constraint on a point, a line, a surface, or a rigid body. So I'm going to select a surface here, and I'm just going to flip my little TV mount over here, and I'll select that surface. So we're dealing strictly with geometry. I click Proceed, and it creates a constraint on there. And you can see over here, it says constraint on Castra. I'm probably pronouncing that wrong. Honestly, I have to admit, I did have to look up what Castra meant. It means fully constrained. So it is, for those of you who know FEA, that is a 1 through 6 constraint on there. But it basically is saying it's fully locking that surface in place. I can right-click on this, and I can change the different types of constraints there, whether I want a translation or rotation, or I can just come to user and say what directions in translation and rotation I want to constrain. But I do want this base fully locked in place. Then I'll come back to my linear static load case here, and I want to create a distributed load. I'll select a surface for that, and let me rotate my model around. And I'll pick that surface right there. I click Proceed, and it creates my distributed load. If I right-click on this, I can set a direction, global X, Y, or Z, normal, long line, surface normal. So I want it to be in the global Y direction. No, I'm sorry, in the global Z direction. There we go. And now I can right-click on that, say Edit Value, and I'll just give it a pressure load here of, we'll say -3. And now I can view my my pressure graphic there, showing me that the pressure is now pushing down on that surface. And that's it. I have now set up everything that I needed to do. I've established materials, I've established a contact between everything, and I've created my my linear static load step. And so what I need to do is I need to save this before I can go anywhere. So we'll say this set up. We'll save that right there. And now I could come and run the analysis. But before they do that, let's talk about a few of the different icons here. I do have this measure icon. What it's going to do is it's going to create a bounding box around the entirety of the part. It's going to show me a couple of measurements on there, so I can just get an idea of the size of my parts. I see I'm at 36 inches by 13 inches by 18 inches.